This is for Year 10 Methods Pathways. We're going to look at exercise 10.4, question number 2. Now, this is to do with without replacement type question. Okay, 2 balls are taken without replacement from a bag containing 4 green marbles and 7 blue marbles. Draw a tree diagram to represent the situation. Okay, so initially we had 4 green marbles in the bag. So 4 green marbles and 7 blue marbles. Okay, and what's going on? We take 2 of them, okay? So if I were to take a green marble, and if I were to take a blue marble and not replace it, this is what's going to happen. This is what's going to transpire. If I take a green marble, I'll have, instead of 4 green marbles, I'll have 3 green marbles. And the blues remain the same, because hypothetically I've taken a green marble, not a blue one. Okay. In the second case, I've got still got 4 green marbles because I've taken a blue marble, and with the blue marbles I have 1 less. So B, 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 B. Okay. Now, what I'm trying to highlight is that the probabilities of the blue and the green changes. Okay, so originally in the bag, I have the probability of getting green is 4 out of the total of 11. Okay, the probability of getting a blue is 7 out of 11, because that has to add up to 1. Now, hypothetically, if I were to take a green out, what would be my probability of getting green in this scenario? Probability of getting green would be 3 out of a total of 2, 4, 6, 8, 10. 3 out of 10. And the probability of getting a blue would be 7 out of 10. Okay. Now, let's look at the second scenario. Hypothetically, if we took a blue marble and not replaced it, then the probability of getting a green next time would be 4 out of 10. Okay, so we got a total of 10 now. We don't have 11 marbles anymore, but we've taken a blue in this case, so it doesn't affect how many greens there are still left. Probability of getting a blue would be 6 out of 10, which equals 3/5, simplified. Okay, so when we're drawing a tree diagram without replacement, we've got to be mindful that our probabilities change depending on what the previous branch took, okay, if you want to view it that way. So we either have a green marble or blue marble, green marble, blue marble, green marble, blue marble. Okay, initially in the bag I had 4 green marbles, so the probability of getting a green marble would be 4 out of 11, because there was 11 marbles originally in the bag. Now remember, the forks add up to 1, so that automatically means that this must be 7 out of 11. Okay. Now, what if I'm looking at this branch line? If I'm looking at this branch line, what this hypothetically means is, if I were to take a green marble here, what's the probability of getting another green marble? Okay, so if you've taken a green marble already in the first time, in the first grab of the marbles from the bag, then I'd originally had 4, so if I take 1 green out, then I'd have had 3 left. So it'll be 3 out of, and the total will be 1 less as well, so it's 3 out of 10. Okay. Now I don't need to consider the second branch because I know the forks add up to 1. So if this is 3 over 10, that must be 7 over 10. Okay. Similarly, for the second part, if I look at the other branch, use a highlighter to show what I'm talking about. Or if I look at this branch, this branch line, I know that the chance of getting blue is 7 out of 11. If I were hypothetically to take a blue out, what's the chance of getting green next time? Okay, well, green is, we had 4 greens originally in the bag. If I take a blue out, it doesn't affect how many greens I have the next time round, because it's still going to be 4 out of a possible. Well, if I was hypothetically to take a blue out, then I know my total would be 10 now because I've taken a blue out. Okay, and for the next part, this would be 6 out of 10. Okay, again, the forks add up to 1. Okay, now I want to explain this branch line just a bit. If I would take a blue out the first time round, so the probability of getting a blue the first time round would be 7 out of 11. But if I take one out, then instead of 7 blues, I have 6 blues, and out of a total of 10 because I would have taken a marble out. So your total is 10. So these probabilities change depending on what you took, okay, and the total changes as well. Now, I'm not done yet. I need to do sample space and the probability. Sample space and the probability. So sample space, you just list what you get in each branch line. So GG, GB, BG, and BB. Okay, and the probabilities, I'm just going to write prob there. So the probabilities are, for that branch line, GG is 411 times 310. I'll work this out on the calculator. So for next branch, 411 times 7 on 10. So you're multiplying probabilities on each branch line. There you go, 7 on 11 times 4 over 10. There you go, 7 on 11 times 6 over 10. Now I'm going to use my CAS calculator because I'm allowed to do that. So what I'm going to do is, let's work out each of these. Clear all. 4 out of 11 times 3 out of 10. Okay, I'm in decimal mode. I want to be in fraction mode, okay, or standard mode. There you go, 4 out of 11 times 7 out of 10. Then 7 out of 11. 7 divided by 11 times 4 out of 10. And 7 on 11 times 6 divided by 10. Okay, so 6, 14, 14, 21. 6, 14, 14, 21. Okay. 6, 14, 14, 21. 6, 14, 14, 21, and a 55. That's a 55. Okay, so worked out probabilities. Now let's do the maths. Now on the test, this will probably be, the first part of the question, because otherwise you can't do the rest of the question. So, the probability of both marbles being blue. Okay, so out of the sample space, the only probability we want is blue, blue. Probably blue, blue is just 21 out of 55. Okay, so we've done all the hard work here. We're just counting which ones we want, or finding which ones we want. Part B, getting at least one blue. Okay, so you can get at least one blue in these 3 cases. Okay, so you can go probability of GB plus the probability of BG plus the probability of BB. Okay, like I said, this is a longer way, but we can do that. Okay, we can go 14 out of 55 plus 14 out of 55 plus 21 out of 55. We have a calculator. 28 plus 21 is 49 out of 55. Or you can use a complement, because I know that 1 subtract GG, which is not blue at all, gives me the same answer, because I know all the probabilities here sum up to 1. So 1 minus GG, 6 out of 55, equals 49 out of 55. So we get the same answer. Okay, so the only tricky part with these tough questions is finding the probabilities of the next branch, because you have to consider what you took out in the previous branch. Hopefully this helps.